So a wave packet is a group of waves with slightly different wavelengths interfering with one another in such a way that the amplitude is non-zero only in the neighborhood of the particle. This is precisely what we looked at in the previous section. Now we come to the concept of phase and group velocities. When I described the idea of a wave packet, I said you're describing one object, but you're taking multiple waves and superimposing them to form one final wave. So now each of these individual waves will have their own velocity, and this final wave also has a separate velocity. So which do you describe as the velocity of the object? That's a question, right? So we have the concept of phase and group velocities, which are two different velocities. So the phase velocity refers to the velocity of each individual wave which you took and superimposed, and group velocity refers to the final velocity of the superimposed wave packet, and group velocity is what we refer to as the velocity of the particle. In other words, I have 10 waves, I am taking them, superimposing them and forming a 11th wave, which I am going to call my wave packet. So each of these 10 waves has its own velocities, v1, v2, so on up to v10. And when I am looking at my object in terms of the wave nature, I will consider each of these waves and each of these velocities for my calculations or for describing the wave nature. And these velocities are called the phase velocities. But now when I am describing the same object in terms of its particle nature, I am only going to be looking at the wave packet, so that I will get its location and then I know the mass and velocity and so on. So the velocity used in that case will be the velocity of this overall superimposed wave. That is what I refer to as the velocity of the particle, and that is called the group velocity. So that's the distinction between phase and group velocities.